this talk is a little interesting because you might have heard about buffer server. We talked about it. So ideally, we try to make sure that you don't have to deal with buffer server. This is an internal component of Apex. And the other thing that I want to tell quickly is so the unique innovation of Apex is buffer server. So buffer server is a subsystem of Apex which supports multiple features. So like in previous talk, Pramod talked about partitioning, smart partitioning and all. So those things gets implemented in the buffer server. So all the hash codes that he talked about, so that's, and more features like incremental recovery and the tuple delivery, everything happens in the buffer server. So now, what's a buffer server, right? So you can consider buffer server like a mini Kafka. So it's not completely like a Kafka, but it's so there are few things that like it does what Kafka also does, like ordering of the messages, and you can subscribe to a particular offset in Kafka. So you can do that same thing here as well. You can subscribe at a particular window ID. So window ID is an Apex concept. So you can subscribe to that as well. There are few things like purging the data. So those things are also supported in the buffer server. So in case of buffer server, so now we need to define who is a subscriber and who is a publisher, right? The publisher here is your output ports. So when you output any tuple, the buffer server consumes it. And the downstream operators, the input ports, they are the consumers. So, and it's a push model from buffer server to the downstream operators. So in Kafka, it is the pull model. Here, in this case, it will be the push model. So in the next slide, so here I want to show various combinations that we support in the buffer server. So these things you don't directly control it. As and when your application changes, so this configuration happens. So I'll walk over each one of them so that you'll know what all things is happening, right? On the top left, what you can see is the partitioned operators. So we have operator, the downstream operator, which has two partitions, and there is one upstream. And in the buffer server, you can see there is a buffer marked, and the tuples are flowing. So not all tuples will go to all the partitions. So based on the hash code that in the last talk Pramod mentioned, so those tuples will be sent. And here the other one, the upstream with two output ports and the two downstream. So the buffer server contains a buffer. So for each port we allocate the buffers. So this operator has two ports. So we are allocating two buffers. And each output, for the buffer, the subscribers are two different downstream operators. So they are not partitioned, they are separate operators, right? And the next top left, what we have is two downstream operators consuming from the same port. Here earlier we had two ports, now we have same port, but two downstreams. So now they are served from the same buffer. So you are not doing anything. You are just in the logical plan when you are building the application. You are just mentioning how you want your DAG to be set up. So internally, all these mechanisms are set up. And the last one that we have here is, so it's a separate one. So each container can have multiple operators. So now in this case, I have two operators, and they are going to two different downstream operators. So now you can see there are two buffers in a single buffer server, and they are going to the different ones. So likewise, these are the supported configuration that buffer server has. So this is like more of a high-level overview of a buffer server. So now what we will do is we will go in depth as to what kind of data structure internally used and everything. It's more of a deep dive of the buffer server. So, this is what we already discussed. The only interesting thing is we create buffer server in every container. Even in the downstream, we create it because Apex supports dynamic partitioning. Say you want to add a new subscriber to a downstream operator, so the buffer server is already there. It makes life easy. But if there are no subscriber, there is no buffer allocated. So the cost is really minimal. So next, we'll talk about the data list. The Vlad will, the data list is the internet data structure. Vlad will discuss about that.
Now, let me go a little bit back and discuss about like why buffer server is deployed always into the same container as a publisher, right? So this is done so that the lifetime of the buffer server is tied to the upstream container. Basically, if downstream containers die, or like if there is a problem or failure in the downstream operators, they can always go and resubscribe like from upstream operator buffer server. Upstream operator even doesn't see or doesn't know that downstream operator failures. Upstream like works as a publisher and continues to push data to the buffer server, and buffer server completely hides that from upstream operators. So like the only thing that will potentially impact that there will be a backpressure built up. But in general, otherwise, it's completely transparent to upstream operator. So let's take a look at like how that functionality is implemented inside the buffer server. So like, what is done? Like there is a data list that is allocated for every stream, right? So stream is a connection like between output port of one operator and input port of the downstream operator. And data list is basically an ordered collection of blocks. So buffer server works like at a block level, and by default, every block is 64 megabyte. And this is done so that buffer server can efficiently persist that on the local disk, right? There is like a limit on maximum number of blocks that buffer server may keep in memory. It's like in case spooling that is disabled, like it's unlimited, right? So even though like we specify, like we can still like reserve some amount of memory for the buffer server, but if it needs to allocate more blocks, it will continue to allocate. In case spooling is enabled, meaning that buffer server will use local disk like to spill over data, number of blocks will be amount of of memory reserved for the buffer server divided by the block size, and by default. Like allocation is a half gigabyte reserved for the buffer server. This is done for every data list, right? So it's basically done for every port that buffer server works with. So let's take a look at like how spooling is done, right? Like a buffer server. Because it doesn't need to be a fault tolerant, right? Like its lifetime is the same as lifetime of the container itself, and it is used for resubscription or replay of tuples. We can use local disk to persist data that needs to be spooled over from memory, and tuples are fetched like from local disk, right? It's like when a subscriber needs them. So like basically there is like a policy that we have implemented in the new release that disallows spooling of blocks that subscribers didn't process yet. So that that helps significantly with implementing backpressure. In the old policy, it was possible that buffer servers may randomly select a victim for spooling to disk, or it's like evicting the block from memory. So it was possible that after a publisher moves to the next block, but subscribers are still way behind publisher, and there are still blocks between what publisher produced or what publisher delivered to the buffer server and subscribers. It's all those blocks potentially would be evicted, right? And then when subscribers need to when subscriber need to consume those blocks, they need to be fetched from the disk, and that slows down. It also makes subscribers can be very far behind from publisher. So right, if I have a very fast producer, very fast upstream operators, and downstream operators are not able to keep up, all that data will be in the buffer server. And buffer server will, even though it will not be in the memory of a container, it will spool it to local disk, but there will be a significant accumulation of unprocessed data. Right? So there is a way, currently, starting with release 3.0, buffer spooling is enabled by default. If necessary, it can be disabled. And note that blocks, when they're persisted to disk, they're persisted asynchronously, right? So basically, there is a notification done, and there is a separate thread that works on saving block to disk, while when blocks are fetched from memory, from local disk into memory, this is done synchronously. And this is the way how backpressure works in Apex. It's pretty much backed up by the buffer server functionality, right? So when downstream operator slows, it doesn't process data from its input port, meaning that a queue of the input port itself becomes full, and input port stops consuming data from the network channel. When that happens, it means that on the buffer server, subscribers can push data to the network, and they will be stalled. At the same time, publisher continues to push data into the buffer server, and there will be more blocks allocated, right? A subscriber may be still working on block 1, while a publisher may by that time publish 4, 5, 6, up to 8 blocks by default. But once it reaches the maximum number of blocks, publishers will be disabled. So buffer server will stop accepting network, will stop reading from the network on a publisher side as well. And then, when it goes to output port of upstream operator, it will not be able to push data to the network. Its own queue becomes full, and now upstream operator is not able to emit on its own port, right? So it will slow down, and that's the way how backpressure will build up. This is all details for the buffer server. Either have questions?
So is backpressure either stop or go, or is it and does it get higher and higher and higher?
It's kind of get higher and higher and higher, right? So there is multiple threads inside the buffer server that race between each other. So basically, publisher tries to get a new block, right? But there is subscribers that fall behind. So once a subscriber moves to the next block, it releases the one that's available. It will be flushed to disk. It can be completely removed, right? Basically, a subscriber may need that block in case of a failure. It may need to resubscribe later. So we still keep that block around until it's purged, but we unpin it from memory. So at this point, publisher will be able to proceed further. So it's basically there is it kind of stops publisher, but once subscriber catch up, it allows publisher to proceed again.
Yeah, I was just wondering if there's maybe only 3 blocks left, maybe you have backpressure to tell the publisher to slow down.
Yeah, that functionality is not implemented yet. So it's that notification to tell, to get a notification to upstream operator. That's in, I would say, more in thoughts or in design. There is no concrete implementation yet.
In one of the slides,
Yes.
the buffer memory MB is 512 MB by default. So, and this buffer is per container, right? So what's the minimum limit of memory per container, like the least?
This is per port. This memory allocated is per port. So if you have 2 output ports, not the input, then it will be twice this memory. So it depends. Now, you can adjust that as well.
Yeah, it's amount of memory that Apex allocates for a container. It's a sum of all operators' memory plus buffer server memory. So in case there is one operator that requires, let's say, 4 GB of memory that has one output port, it will be 4.5 that Strum will allocate, that Strum will reserve for that container.
Can we reduce this default?
Yes, you can. That buffer memory MB is an attribute on the port, so if you set that attribute, you can set it to a lower value. For application with many ports, if you have a cluster with limited number of resources, for example, if you're playing on a sandbox, it's definitely recommended to lower that amount. It will lead to slower performance, but will let you play with the Apex.
So what is the minimum required for buffer? Yeah. Because one block is 64 MB, would just giving 64 MB?
It's what will happen. If you reduce that amount, buffer server will still allocate 8 blocks, but size of the blocks will go down. So yeah, there is I would say probably 8 MB is you can go as low as 8 MB. It's maybe even less.
Sure.
And note that it also depends on your tuple size. So if tuples are small, you can lower that amount.
How
How many buffer servers you want to create? Who decides that? Is it configurable? Because in the previous slide, I believe 3 diagrams had, two had 2 buffer servers, but what is the relation like?
There is always one buffer server per container.
We create one buffer server and each buffer for one output port. So 1-to-1 mapping between output port and the buffer that we create.